All right, here are the answers to the mental math. We changed this to plus plus, so what we have is 75, basically take away, or 0.75 minus 0.25, so we get 0.5. All right, this one, it's 5 times 10 to the 5th squared, and so up above here, I wanted you to see what that means. It means we have 2 of these chunks, 1, 2. So these are synonymous. When you see this, it's the same as just 2 of them, okay? So now this is something you've done before. 5 times 5 is 25, and then this would be times 10 to the 10th, okay? But 25 is not scientific notation. 2.5 is. So it goes to 10 to the 9th. It goes down 1, okay? No, it doesn't. I'm sorry, I was thinking about negatives. This is 10 to the 11th, right? All right. Mistake there, but I caught it. Yay me, I got a starburst. All right, m equals 25 on this one. And this one, square yards to square feet. Well, remember there are 3 feet in a yard and there's 2 of them. So what we basically do is 1 times 3 times 3. We get 9, or 3 squared, okay? If you needed to do that on some paper, that was okay. And I kind of showed it there. Those are my yards. So 3 times 3, 9 feet squared. Okay. 200% of 25. So 100% of 25 is 25. So 200% is double that, 50. And then 200% more than 25, we add 50 to 25, we get 75. So there we have our mental math. Right here we're going to be doing areas and with circles and all that kind of stuff. So a semicircle, just so you know, is half of a circle. Okay, so the length of a semicircle is half the circumference of a circle. So if we were looking for the distance from here around to here, which we will be doing, we take the circumference as if it was a whole circle and just cut it in half, right? So just to remember, the formula for circumference equals 2 pi r, or circumference equals pi times diameter, right? Okay. I don't know why I have a shadow there. It's kind of bugging me. All right, so let's look at this picture. Find the perimeter of this figure. Dimensions are in meters. Now, part of this is easy, part of it is not. What we really know as far as the outside edges of this figure is that this is 4 and this is 4, right? We do not know what that is, or do we? And we do not know the distance from here to here without using a formula. All right, so let's tackle this first, this unknown edge here. We do see here that this radius is 5. That means this is also 5, doesn't it? And this is 5. So this actually is 10. Okay? You just have to be able to see that. They don't spell it out for you and hand it. They want you to know how to get it, okay, by using the radius. So now we've got 4, 4, 10. So we know our final answer for the perimeter will be 18 plus something, right? So let's figure out what the circumference, if this was a whole circle. The circumference would be, we have the radius, so I'm going to say 2 pi r. So the circumference, and we're going to use 3.14 for our pi and 5. Okay, now this isn't too bad because we get 10 times 3.14, and we love multiplying by 10 because we can just move a decimal, and that is 31.4. So that is if we had a whole circle, isn't it? But we don't actually have a whole circle. We have half of a circle. So we can take this and divide it by 2. Now, and we could go do that off to the side. But let me show you something. We can divide that whole thing by 2, or we could have done this. Divide by 2 right here. And then the 2 and the 10 cancel. So we have 5 times 3.14. And that will give us the semicircle, right? Okay, we've got 2 behind the decimal point, so we get And I'm going to do the squiggle again, because remember we don't know, or we do know but that we're rounding. So it's 15.7 is the semicircle. So around here, if you wanted to, I don't really do this, but you can kind of write it like that. So you realize that the curve is about 15.7 meters. Okay. Now what we would do to find the perimeter is add these all up. So perimeter, we already have 4, 4 and 10, like I said, is 18. So the perimeter is 18. We're going to say about 18 plus 15.7. And when we do that, we get the perimeter is about 33.7 meters. Okay. So these are fun. Yes, I showed a lot of work, and you will too, but no one's hurt, no one's bleeding, everyone's fine, okay? Nothing major has happened. We just did some showing of our work, okay, which is fun. So now it says find the area of the figure in example 1. Dimensions are still in meters, okay? So the area of this rectangle, let's do it in parts, right? In the book they might say, okay, this is area 1 and this is area 2. I like to use my easier area for area 1. Okay, area 1 equals length times width, okay, equals 4 times 10 equals 40. So there's my area 1, meters squared. My area 2 is a little bit harder because it's half of a circle. Now remember, the area of a circle equals pi r squared. Remember, don't be tricked, okay? However, we want half of a circle, not the whole thing. So we're going to say area 2 is pi times radius squared divided by 2. And then we're going to plug in what we know. We have 3.14 times 5 squared over 2. Okay, and I'm going to have to bring my work up here, which equals 3.14 times 25 divided by 2. Yes, that's a lot of calculating, and I'm here to be kind for you. You could do 25 divided by 2, and when you do that, you get 12.5, and then you multiply 12.5 times 3.14, and yeah, it's still not fun. So for today, I'm actually going to just tell you that is about 39.25 meters squared. So then we add our two areas together, and I'm going to say area total equals 40 plus 39.25, and that is about 79.25 meters squared. So let me do the squiggles there. Okay, whatever that's called. I should look that up. Or one of you could look it up and tell us what the equal sign is called, what that symbol is called when it's about equal to, but not fully, but it's been rounded. Okay, we can also calculate the lengths of arcs and areas of sectors by determining the fraction of a circle represented by this arc or circle, okay? So in this case, we're trying to find this shaded region here. Okay, so first up here, a semicircle was half of a circle, so we just cut everything in half. What fraction of a circle is this little piece of pie here? How do we figure that out? Well, if all the way around a circle is 360, and we have 300 here, all the way the part that's not shaded, in here we have about 60 degrees of 360, right? So this fraction, I'll just show you where I get it, is 1/6 of the whole circle. So if we find the area of a circle, of this circle, and divide it by 6, we will have the area of just that little piece of shaded sector, okay? So the area of the shaded region, we'll do that, equals pi r squared divided by 6. And pi, we're going to go ahead and use 3.14. Next year it'll be fun because I'll let you leave stuff in terms of pi and you'll have a lot less calculating. Life will be a little bit easier in that sense. Okay, 6 squared over 6. So that reduces to about 3.14 times 36 over 6. These guys cancel out. And did that off to the side here. Got 18.84. So our final answer is 18.84 centimeters squared. Okay, now we're going to look at the next page. I'm going to talk to you a little bit about arcs. Okay, circles have arcs. I'm going to draw a picture up here. I'm going to put 3 points on the circle. How about I have a B and C. Okay, so let's talk about, if I'm talking about this arc, this is this piece of circumference between A and B. We call that a minor arc, okay? Because it is less than a semicircle, okay? There are less degrees than a semicircle. And so we call that, the way we write arc AB would be this, okay? Now, if I wanted to talk about, so that's a minor arc. A major arc is greater than a semicircle, and ABC, this part, is a major arc, ABC, okay? And we state that the same way. You could also say ABC, the major arc over it, or with an arc over it. Okay, arcs can be measured in degrees. There are 360 degrees in a circle, okay? So, if we knew the measure of, or the degrees in AB, we'd subtract that from 360 to get the major arc, ABC. Okay, so let's look at example 4. And I see here we've got a circle that I did not complete correctly. There should be another point on this circle about here, and we're going to call that D. So go ahead and label that D. I just didn't do that ahead of time. Okay, so in this figure, the central angle AOC is 70 degrees. So this is 70 degrees. You can go ahead and write that in there. Okay. What is the measure of ADC? Now this is 70, and that means this arc is also 70 degrees. Okay, so you could write 70 degrees out here. And we want to know the measure of the major arc ADC. Like we said, all the way around is 360. So if we do 360 minus 70, we will get 290 degrees is the measure of ADC. Okay. Now let's look at example 5. Okay, a minor arc with a radius of 2. As you can see here, here's the center out. Has a radius of 2. Is drawn from the positive axis to the positive y-axis. So positives, positives. What is the length of this arc? Okay, so we could figure out if this whole circle was here, what the circumference would be. And because this is 90 degrees, this arc is 90 degrees, and that's a fourth of the circle. So we take the circumference of the whole circle and then divide it by 4. So if we were to write a formula for that, we'd say our arc equals pi times diameter, or 2 pi r, divided by 4. Okay, and we will go and put in what we know. Our diameter is twice our radius. Whoops, yes, so 4 over 4. Now, isn't that nice? Because these cancel out. And so, whoops, those are squiggles. So our answer is about 3.14 units for the length of this arc. All right, the rest is practice, so I want you to go ahead and give that a shot. Come back if you need help, and check your answers in the solution manual or back on the video. All right, you may begin. All right, so find the perimeter. Find A, the perimeter, and the area of the figure. Okay, so when we look at the perimeter, we first have to go from here to here to here to here to here, and then half of this circle, semicircle here. Okay, so I might go ahead and figure out the semicircle first just to get it over with, and it looks like my radius is 3. So the circumference equals 2 pi r, or pi d, so that would be pi times 6, and we're dividing it by 2, okay, which is about 3.14, and I'm going to cancel these out, times 3. That is our circumference. Okay, so I'm going to go off to the side, 3.14, and multiply that by 3, and we get 9.42. So in here, this arc is about 9.42 centimeters. Okay, now we have to add our 3's, our 4, and then, what is, if from here to here is 4, right, what is from here to here? Well, we've got 3 and 3, so it looks like all the way our length is 10 altogether, okay, or 6, there. So the whole length is 10, so we're going to go 3 plus 10 plus 3 plus 4. Okay, so that's going to be 20, isn't it? Let me double check that. 6 plus 4 plus 20 is, or sorry, plus 10 is 20. So if we add 20 to our arc that we had, we have 29.42 centimeters for our perimeter. Okay, now area. In here, I'm just going to write it. Area equals length times width, and our length is 10, and our width is 3, so our area is 30 centimeters squared. And now I need my area of the circle, but it's divided by 2. So area equals pi r squared divided by 2 in this case. Pi is 3.14. Radius is 3, so we square it and divide it by 2. So we've got 9 times 3.14 divided by 2. Okay, so we've got some calculating to do, and that's okay. So I'm going to go first over here. Whoops. We could do 3.14 divided by 2 first. So I'm going to go ahead and do that. Keep our numbers smaller. Hope that I get a nice, so we get 1.57. Okay, so now I'm going to do 1.57 times 9. So I did 1.57 times 9, I get 14.13. So the area of that semicircle is about 14.13, and we add that to 30. So our total area is going to be 30 plus 14.13. So I'm going to go ahead and write it here. It's about 44.13 centimeters squared, and then box it really nice so my teacher can see my final answer. Okay? And we've got 2 more. Find the area of the 45-degree sector. Leave pi as pi. Now that's always a gift, and I'll show you why. It means you don't have to calculate it. So 45 degrees, let's see, what fraction of a circle is that? 45 out of 360. Okay, well, it's an eighth of it. Okay. 45 times 8 equals 360. So that's an eighth of a whole circle. Or just think there's 2 45s and a 90, and there are 4 90s in a circle. So I don't know if that meant anything to you. So what we're going to do is we want 1/8 of it. So if we want the area equals pi r squared divided by 8 in this case. Okay, and we're going to leave it in terms of pi, so we don't have to do the squiggly about equal to. It is equal to pi times the radius, which is 4, squared over 8, okay, which equals 16 pi over 8. And then these cancel out. So our final answer is about 2 pi, and that's what I mean leaving it in terms of pi. We don't have to multiply it by 3.14. So that's 2 pi centimeters squared, and it's not about equal to, it is equal to. Okay, now we're going to find the perimeter of that. Which means include, we have to find the length of this and add the 2 edges of our pizza. Okay, so it's going to be 4 plus 4 plus 1/8 of the circumference. Okay, well, the circumference equals pi d and then divided by 8, right? And then we're going to add 4 plus 4 to our final answer. So if we do that, we've got 3.14, oops, squiggle that in, times our diameter, which is double 4, which is 8, over 8 plus 8. Lots of 8, huh? Now isn't this nice? We get to cancel out those 8s. So our final answer is 3.14 plus 8, and that equals 11.14 centimeters. And there you go. Kind of fun. All right, and that